All right, so a permutation and a combination. This is read, the permutation of 9 things taken 3 at a time. So I might have 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to use 3 of my numbers, and I want to find out how many different arrangements I can have. And a permutation, the order is important. 1, 2, 3 is not the same thing as 3, 2, 1. For a combination, the order doesn't make a difference. It's like having a group. The group 1, 2, 3 is the same thing as the group 3, 2, 1. So permutations, you have a lot more options because the order of my arrangement makes a difference, whereas a combination, you think of it as a group, you're not going to have as many choices. When I do a permutation of n things taken r at a time, you take n factorial over n minus r factorial. For a combination of nr, we take n factorial divided by n minus r factorial times r factorial. So we get rid of all the extra ones where they're exact same group of things. Now factorial means you take that number, like 9, times every number below it. So 9, 8, 7, 6, 5, 4, 3, 2, 1, till you get down to 1. So if I am going to evaluate the permutation of 9 things taken 3 at a time, I'm going to do 9 factorial over 9 minus 3 factorial. 9 minus 3 would give me 6 factorial. So if I think about this the long way, 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. Notice, everything below 6 factorial is just going to cancel out. So I'm going to take 9 times 8 times 7. 9 times 8 times 7 is 504. For my combination, if I have 11, 4, I have 11 objects, I'm going to take 4 at a time. I'm going to do 11 factorial over 11 minus 4 factorial times 4 factorial. So 11 minus 4 would be 7 factorial. 7, 8, 9, 10, 11. So when I think about this, 11 factorial would be 11 times 10 times 9 times 8 times 7 factorial, because it's 7, 6, 5, 4, 3, 2, 1. Since I already have a 7 factorial, I'll be able to cancel those out. Then I have the 4 factorial. 4 times 3 times 2 times 1. So I can do some reducing. I have an 8 and I have a 4 times a 2. Well, 8 and 4 times 2 are both 8, so I can cancel that out. 3 and 9. 3 goes into 9 3 times. So I can take 11 times 10 times 3. 11 times 10 times 3 gives me 330. Now, just for purposes of checking, not that I think that you should use your calculator to figure these out, you do have a permutation and a combination button on your calculator. It happens to be right next to the x to the negative 1 underneath your alpha key. You see in yellow is NPR, the key says NCR. So if I were doing this permutation, I'm going to put 9, shift, the NCR key, but it really puts the P in there because the shift gives me the one above it. So 9P3, if I hit equals, I get 504. If I'm doing the combination, 11, just the NCR key, which gives you the C on your screen. So 11C4 gives me 330. So do it on your paper, but if you want to double check it on your calculator, you do have the combination, which is the regular key, and then the permutation where you have to hit the shift button first. So put the number in. If you want the permutation, shift in your combination key. If you're doing the combination, the 11 and then the key. Number 20 then. They switched them around. So I am going to have 9 things taken 4 at a time. I'm doing a combination, which means the order doesn't matter. And so I would do 9 factorial over 9 minus 4 factorial divided by that extra 4 factorial, since I'm going to have fewer choices. This would make this 5 factorial. So 9 times 8 times 7 times 6 times 5 factorial. 5 factorial times 4 times 3 times 2 times 1. So that will cancel. 3 times 2 is 6. 4 goes into 8 2 times. So 9 times 2 times 7. 9 times 2 times 7 gives me 126. So 126 would be my first answer there for my combination of 9 things taken 4 at a time. For 8P3, a permutation of 8 things taken 3 at a time. I'm going to have 8 factorial over 8 minus 3 factorial. So I'm going to have 8 times 7 times 6 times, this would be 5. 5 factorial. 5 factorial on the bottom. My 5 factorial is going to cancel out. So 8 times 7 times 6 gives me 336 permutations. Number 21. 4P3. I'm doing a permutation, 4 factorial over 4 minus 3 factorial then, which is 1. So 4, 3, 2, 1 factorial divided by 1 factorial. 12 times 2 gives me 24. Possible ways to have that. And the last one, 12C4, I'm going to have 12 factorial over 12 minus 4 factorial times 4 factorial. 12 minus 4 would be 8. So 12, 11, 10, 9, 8 factorial. I've got 8 factorial on the bottom, and then I've got 4 factorial, so 4 times 3 times 2 times 1. 8 factorial is going to cancel out. 4 times 3 is 12. 2 goes into 10 5 times. So if I take 11 times 5 times 9, I get 495. So for a permutation, you're going to have more choices because the order is important. Combination, you divide by that extra to divide out those extra possibilities, because 1, 2, 3 is the same group as 3, 2, 1. And so you have fewer choices there. And so those are your formulas. On the next ones, we will be doing some word problems doing those things.